Hello. So we're going to make a few connections between the graph of f, f prime, and f double prime. So when you see something like this, the first thing that you should be doing is labeling the graph. So right here it says, given below is graph of function f of x. It says it down here, but I want to make sure it's very clear because you're going to be pretty upset if you consider this as f prime or f double prime the whole time it's been f of x. So this should be all things you know. F of x, when f of x is increasing, f prime is positive. So f of x is increasing. And I see that this happens on the intervals from negative infinity to negative 4. From negative 2 to 1. And that's it. So I'm going to say, therefore, f prime is greater than 0. So stuff that you already know. Likewise, I can say when f of x is decreasing, and I can see that from the graph, so I'm really justifying before I ever say anything about f prime. But f of x is decreasing, and I can see that happens from negative 4 to negative 2. So from here to here, and then from 1 until infinity. Therefore, f prime is less than 0. If I wanted to, I can also say when f prime is equal to 0, and that's when f prime is changing from positive to negative. So f prime is going to be equal to 0 and f of x changes from increasing to decreasing, increasing to decreasing, or vice versa. And this happens at x equals negative 4, and x equals negative 2, and x equals 1. And at these values, if f prime is equal to 0, that means f of x is neither increasing or decreasing. So right here, here, and here. This is the one that's a little bit crazy though, f double prime, just because we've been talking about this one just recently. F double prime deals with concavity. So f double prime of x is going to be greater than 0 when f of x is concave up. And so I'm going to go through and I'm going to see when this happens. So f of x is concave up. So concave up looks like this. I'm going to see where does that happen. Well, here I can't really tell, is this down or up? So I'm going to pick a value, and it would be very specific if you had to do something like this. But I should get another color. I can see concave up. Oh, that's really hard to tell. From about here to here. It would be very specific. You would be given something that says like f of x has a point of inflection at x equals negative 3 and x equals 0. And then over here I can see it's going to be concave down, concave down. So f double prime is greater than 0. That's the conclusion I'm reaching. I'm giving my justification. This happens when f of x is concave up. This occurs on the intervals and I'm going to say from negative 3 to 0. Again, this is just a guess right here. You would be given much more specific information so you can figure that out. F double prime of x is less than 0 when f of x is concave down, which occurs from negative infinity to wherever I said this value was, so to negative 3, and then from 0 to infinity. And then I could also say what the points of inflection are. On this graph, I'm using x equals -3. I might even want to use like -3.5. So this would have been fine if you would have said -3.5. And then x equals 0 are points of inflection on f of x, which means for f double prime of -3 and f double prime of 0 are most likely going to equal 0, because what's happening is I can see right here f of x is changing from concave down to concave up, which means f double prime is changing from negative to positive. If f double prime is changing from negative to positive, it's most likely passing through 0. So f double prime of -3 and f double prime of 0, I'm going to say, in this case, a function that looks like this, I'm going to say that are equal to 0. This doesn't have to be the case. They could not exist, but because I can see what's happening with the function here, that's most likely going to be the case. Most likely. And in this case, it would be. Okay, so that was on page 109. So next one, we're going to go to 110. And I can see this graph looks a little bit different. But this one says, given below, the graph is the function of f prime. And it says it down here, but I'm going to write it really big and label it so I definitely remember. This is all things you know. So this is just reviewing what you already know and convincing you that you know that. So f prime of x. So conclusions about f of x. Well, I know when f prime of x is greater than 0, that means when f prime of x is greater than 0, I can see that this occurs, I'm going to say, that means, this is a weird thing for, that means f of x is increasing. I worded that strangely. This occurs, f prime of x being greater than 0. It's going to be here, any positive values. So on the intervals from -2 to 1, and then 3 to infinity. I'm writing strangely, so this means f of x is increasing. This occurs, I should say, on the intervals. Then I also want to know, okay, so I've got f of x, and when f prime of x is greater than 0, I could say, and I'll word this one a little bit better, f of x is decreasing when f prime of x is less than 0. And this occurs on the intervals. Negative infinity to -2, and then 1 to 3. I also can see right here that f prime is changing from negative to positive. So f of x has negative to positive. Think about that. That would be decrease and increase. So has a relative min at x equals -2. And the same thing is happening over here at x equals 3. And the reasoning as f prime changes from negative to positive. And I'm definitely running out of room. But I can also say when f of x has relative max, which would occur right here. I'm going to squeeze this up above. No, I'm not. F of x has a relative max at x equals 1 as f prime of x changes from positive to negative. And whether it's in your head or on paper, if I'm thinking positive to negative, I'm always writing this out so I don't accidentally mess up which one's max and which one's min. Okay, so this is old stuff. You should remember this. We've gone over this a whole lot. If you don't rewatch this part, ask me questions about it. Watch other videos, Khan Academy, there are other YouTube videos. This part should be pretty well cemented in your head. This is the new stuff. So conclusions about f prime, or f double prime. But it's not too new. So this is a graph of f prime, and this is conclusions about f double prime. This is the slope of this graph. So f double prime is the slope of f prime. So the relationships between f of x and f prime still apply. So let's say I want to know f of x, or f double prime, is going to be greater than 0 when f prime, think about this, if I just said f prime is greater than 0, that would mean the slope is greater than 0. Slope is positive when whatever function we're talking about, whatever it's the derivative of, is increasing. And this would occur intervals. So I'm going to say negative infinity to negative 1 and 2 to infinity. Likewise, f double prime is less than 0 when f prime of x is decreasing. And you can see where this is happening. So from negative 1 to positive 2. I'm going to say on the interval, so it doesn't just look like I'm talking at a point. So I have this relationship going on where f prime of x is the, like, acting like f of x in this case, and f double prime is acting like f prime. You know, there's still f double prime and f prime, but f double prime is the derivative of f prime. So don't think of this as all new information, just you have to slightly tweak what you already know in order to incorporate these new facts and new relationships. I could figure out when f double prime is equal to 0. And so what I would do here, I would say f double prime is equal to 0, and then I could figure out when f prime changes from increasing to decreasing. So I could say this. So f double prime of x, f double prime of x. Do you see how it has a horizontal tangent right here and right here? So f double prime of x equals 0 when x equals negative 1 and x equals 2. And even more so, it's really beyond f double prime equaling 0 because there's a horizontal tangent. It's actually changing from positive to negative or negative to positive. Because this is happening, because f double prime is changing signs, I can also reach one more connections about f of x. That means the graph of f of x has a point of inflection at x equals negative 1 and x equals 2. I can also tell some other facts too. So if I wanted to keep going, because this is actually talking about this column now, if I wanted to say f double prime is greater than 0, I also can figure out that f of x is concave up on these intervals. I also can figure out that f double prime, because it's less than 0, f of x is concave down. So it gives you all relationships about each of these. So f prime, if I'm given that graph, I can figure out a lot of other information. Okay, so one more graph first to look at right here. And this says this is the graph of f double prime. I know that you were hoping this would be the case because you're like, I did f prime. I really hope we get to the graph of f double prime. Well, here's your wish. So state all the conclusions that you can reach about the graphs of f of x and f prime of x. Okay, so f of x and f double prime. Here you're talking about concavity. F of x is concave up when f double prime is positive. Now I'm going to go to my graph, and I can see that this happens from 0 to 3, and then 3 to infinity. Sorry, I'm listening to the monitor, and my son's coughing. So on the intervals, sorry, this looks really bad, but I'm not actually going to fix it. I'm writing in a marker, so that's fine. Then I'm going to say f of x is concave down. I'm giving the justification really before I even figure out the intervals to make sure that I'm getting the correct intervals. And I can see that this happens on the interval from negative infinity to 0. I can also say that f of x has a point of inflection. When f double prime changes signs. This happens right here. Not at this value. I know that f double prime is equal to 0, but it doesn't matter because I'm talking about when does it change signs. So right here, f double prime is changing from negative to positive. So this occurs at x equals 0. Here we've got some other conclusions now about f prime. Remember, this would be like looking at the graph of the derivative, and this is the original function. Or because this is f double prime and f prime, this has the same relationship as if this was f prime and this was f of x. So, conclusion about f of x. F double prime, if I say f prime is increasing, for instance, when f double prime, and I can see that's actually what's happening over here. So this happens on the intervals, So it's actually the same place as what's happening over here, because it's still when f double prime is greater than 0. F prime of x is decreasing when f double prime is less than 0. And it's going to be the same thing. It's going to be this green that was up here before. This occurs on the interval negative infinity to 0. I can also figure out where f prime of x has a relative, I can see right here negative to positive will be a relative min. So f prime of x at x equals 0 as f double prime, so its derivative, changes from negative to positive. And I can also say that f prime does not have a relative max, so it's not over here. There's a horizontal tangent happening over here, but it's nothing more than that, because I can see that f double prime is positive, then positive again. So increasing and then increasing again. There's just a moment with a horizontal tangent somewhere around there. So I'm just saying f prime changes from positive to negative, and there's no relative max for f prime. As f double prime of x does not change from positive to negative. Thanks for watching. I hope this was helpful. Yeah. Have a good night, day, whatever time you're watching it. It's pretty dark right now, so it's night for me. But yeah, I hope you're understanding this. If not, ask me some questions or watch some more videos, mine or other people. There's lots of this stuff out there, and this connection is going to serve you really, really well if you know it well. Thanks.